Here we are, Statistics and Mechanics Year 1, Chapter 7, Mixed Exercise, Question 6. The manager of a superstore thinks the probability of a person buying a certain make of computer is only 0.2. To test whether this hypothesis is true, the manager decides to record the make of computer brought by a random sample of 50 people who brought a computer. Find the critical region that would enable the manager to test whether or not there is evidence that the probability is different from 0.2. The probability of each tail should be as close to 2.5 as possible. Okay, so part A. We have the number of people who brought the computer is binomially distributed with a sample of 50, and the probability that they brought the computer is 0.2. Null hypothesis is going to be that the probability is 0.2 that they buy the computer, and the alternative hypothesis is that it is different. Don't know if it's higher or lower, so it's just not equal to. This is a two-tailed test, and we've been told to make both tails as close to 2.5%. So we're testing a 5% significance level, but 2.5 in each tail. So 0.025 in a two-tail test. Okay, so we need to find the gap between these. Let's have a look. Let's start with the lower portion of it. Okay, so I'm going to look at the probability of, let's see, 20% of people buying it. If we had 5 people buying it, that's 10%. Let's go with 10 people. So x is less than or equal to 10, okay, is going to be equal to, using a calculator, here we are, just go back a few steps because we've got to set up on a binomial. Number of trials is 50, okay, and our probability is 0.2. And now we can look at the probability being less than 10, okay. Okay, and I can see straight away that it's a ridiculous one to try, 0.58. Okay, so 0.58 is not smaller than 0.025. No good to us. Let's half that. Probability of x being less than or equal to 5 equals, put it in, so 5 this time, 0.480, close but not quite there, 0.48, okay, which is still no good to us. Okay, so let's look at 3 because we're still quite a long way away from it. Okay, so putting it in, 3, 0.005. Okay, so that's quite small, isn't it? 0.005, so that's 0.5% when we're looking for 2.5%. So that one does satisfy it. Okay, let's see what's in between there in terms of x being less than or equal to 4. Okay, so just put it in for 4 and see what we get. 184. Okay. 0.184. No, 0.184, wasn't it? 0.184, yes. Okay. So that one is also good. All right. So that looks like a good mark there for us to be in here. It's quite close to, it is closer than the 0.48. Okay, that was 0.048, wasn't it? Okay, so we're going to go with that as a lower bound of a critical region. So now let's jump towards the probability of it being greater than. So we're going to look at probability of x being greater than or equal to. Now we know 10 got over the 50% mark, so let's go for 17. Okay, which of course is going to be 1 minus the probability of x being less than or equal to 16, which is equal to 1 minus, let's go find out what the number is, 16. Here we are, 1, 6, okay, 9855. Put it in there, doing the takeaway, 1 minus 0.9855 gives us 0.0145, which is less than 0.025. Okay, so that is a good result. Let's try something a bit smaller. Let's try it at 16. Okay, which of course is 1 minus probability of x 15, which is 1 minus, and if we just come in here, 15 this time, okay, 9691. Okay, 0.0309. So 3%. Okay, 0.25. All right, which doesn't work. Now, let's just have a quick conversation about what's going on here, because there is this line: the probability of each tail should be as close to 2.5 as possible. So if we were to use this one, that is correct, okay, rather than this one. So just looking at the probability of x being less than 5, okay, was 0.048. If you do 0.048 take away 0.025, the difference there is 0.048 take away 0.025 is 0.023. And looking at this one down here, 0.0184. Okay, and again doing the absolute difference on the takeaway, okay, because we're just looking at the difference. 0.025 take away 0.0184. I'm taking an absolute on that, okay, and it comes out as 0.065. 0.0066. Okay, clearly this one is smaller, so we will use this. Okay, definitely x being less than 4. Now look at these two results we've got here. Do exactly the same. Do 0.0145 take away the 0.025 and also do it on the 309. Okay, so that we can see them both. Okay, so 0.0309 take away 0.025 is 0.0059, and when we do it up here on the 0.025 take away the 0.0145, okay, we end up with 0.0105. So just doing that takeaway like we did on the one above, this one is smaller. This one is closer to the 2.5%. So we will use this one. So critical region, Okay, so the critical region is X has to be between the 4 and X has to be between the 16. Okay, so if we want this to be true, we need it to be in between the 4 and the 16. Okay. Okay, so there's part A, 4 and 16. Good. What's the next part? Part B. Write down the significance level of this test. Okay, so the significance level of this test is using the probabilities or the results from here and here. Okay, so the significance level, they wanted it as close to 0.025. They wanted it as close to 5% as they could get there. So the significance level is 0.0184 plus 0.0309. Okay. Okay, and that gives us a 0.0493, so 4.93% is the significance level that we're confident about this test, and it's not just happened at random. Okay, and finally, 15 people buy that certain make. Comment on this observation in light of your critical region. Okay, so 15 people. Let's see. 15 people is not in the critical region. So not enough evidence to reject HO. Okay, so probability someone buys the make of PC is 0.2. We are accepting a hypothesis. Okay, so 20% of people buy that PC, even though 15 out of the 50 purchased it. Okay, which is fine. Okay, right, done.